Hi! Today we're going to see how more precise types can help us when we write programs. So let's start by looking at a typical Haskell function. So here I'm trying to look up something which, taking a list of A's and an integer, gives me back the element at the position of the integer. So that's this function in the Haskell prelude. You can see what it says. Wait a little bit. So it's the list indexed operator. So let's see if we can write this in Agda. So I've already prepared something like this. Here we go. So here we have the data type of lists that we have seen before. So we have the empty list and we have a cons of a head and a tail. And here I wanted to write this lookup operator which takes a list. And then in Agda, we don't use integers so much. We normally use natural numbers. So let's middle click on that to see what the definition of this is. This is something you can do in general. And so here we see what the definition of natural numbers are. We see that a natural number is either 0 or it's the successor of another natural number. So we get 0, then we get the successor of 0, which is 1, and then the successor of 1, which is 2, etc. And this way we can get all the natural numbers built up. Okay, so now let's go back here. So this is a good thing to index into lists, right? Because we don't really want to index with negative numbers, for example. We just want the positive ones. So the natural numbers are a perfect fit for this. Okay, so we are given a list x's and a natural number n, and we want to get the element at the nth position in x's. So here we have two choices, right? We have to produce an A, and we have two things to look at. So I can look at the context. I have a natural number and I have an x's. So we either have to look at the list or the number. So I'm going to start looking at the list. So I do Control-C, pattern match on the x's. And I say that I have two cases to consider. It's either the empty list or it's a head followed by a tail. Okay, so let's deal with these cases first. So if it's a head followed by a tail, then we have to look at the number to see which one we want, right? So let's pattern match on the n, Control-C, pattern match on n, press enter. And we say that we have two cases. The number is either 0 or it's a successor of some other number, right? So if it's 0, then we're lucky because we want the 0th element in this list, and we have the 0th element right here, so we can just return the x. Right. Okay, I'll reload just in case. And let's look at this case. So here we want the n plus 1th element in this list, which consists of an x followed by some other things. Right. So if we take the nth element in the tail, that should be the same thing as taking the n plus 1th element in the whole list. So here we can do a recursive call saying that in the list x's, I want to look up element n. Keep that, and that works. Okay, so far so good. But what about this case? So here we have a natural number n. It could be 0 or successor, we don't know yet. But we have the empty list. So we're trying to look up some element in the empty list, which is never going to work. So we see that here we actually have a problem because we don't know what the type A is, so there's nothing we can return here really. Right? The A could either be an empty type, in which case we are given nothing, just an empty list, and we're asked to produce something, namely an element of A. So there's nothing we can do to put in this hole to finish this program. So if we try to do this in Haskell, with the built-in function, trying to look up, say, the second position in the empty list, then you see that here I get an exception. But in Agda, we are not allowed to have any of these partial programs that throw an error when something goes wrong, because we want to use our programs as evidence that certain things happen. So in Agda, all programs always terminate without an arrow, which means that we can't fill in this hole. So we have to think of something else to do, which we are going to do in the next video.